Understanding the changing energy balance of Earth. Greenhouse gases hit record high by 2024. Carbon dioxide, methane, and nitrous oxide in the atmosphere reached their highest concentrations in over 800,000 years, permanently altering the Earth's radiative balance. Mechanism of energy imbalance. The primary cause of this heat retention is an Earth energy imbalance where the inflow of solar radiation is greater than the thermal energy that can escape back out to space due to these dense greenhouse gas layers. Surface and tropospheric warming trends. The last 176 years of global temperature data for near-surface temperatures show the last 3 years are the warmest on record, and 2025 is the second or third warmest year globally, driven by changing patterns of El Niño and La Niña. Trapped thermal energy distribution. Oceanic heat uptake. As the mains sink, the vast majority of trapped energy is absorbed by the global ocean, which will reach record levels of heat content in 2025, suggesting a continued long-term accumulation of energy. Atmospheric heat storage, the rise in surface and tropospheric temperatures, is the most visible indicator of climate change, but it represents only about 1% of the total excess energy currently being stored in the Earth system. Cryospheric impacts and mass loss. Approximately 3% of excess energy goes into melting land-based ice. 8 of the 10 worst referenced glacier negative mass balance years have occurred since 2016. Arctic sea ice has seen a constant decline in all seasons since 1979, whereas Antarctic sea ice, which had been experiencing slight growth, has seen record low minima in the past 4 years. Continental heat storage, the 5% of excess heat energy that remains, is absorbed by the Earth's land masses, raising subterranean temperatures over time and disrupting intricate terrestrial processes and local ecosystems. Cascading effects on global systems. Accelerated global mean sea to level rise, a combination of thermal expansion of warming ocean waters and the contribution of meltwater from glaciers and ice sheets, have accelerated global sea level rise since 1993. Oceanic chemical shifts. The ocean itself has not only been a heat sink, but it has also helped mitigate climate change by taking in roughly 29% of human-made carbon dioxide emissions, though this has led to ocean acidification as it has decreased the pH level of seawater. Socioeconomic and humanitarian implications. These systematic physical changes are threat multipliers, where climate hazards intersect with high vulnerability and low adaptive capacity to fuel widespread food insecurity and human displacement. The value of observational monitoring, reliable long-term data sets are still essential to track these rapid, large-scale changes and advance our global understanding of the shifting climate reality. Integrated responses of the Earth system. The complexity of these interactions proves that climate change is not a localized event, but a holistic transformation of the physical, chemical, and biological stability of the planet across all major spheres of the environment. Future outlook and mitigation. The necessity to reduce emissions because the present heat buildup is directly related to greenhouse gas emissions. The rate of future energy imbalance depends on human activity and the stabilization of the concentrations of gases in the atmosphere. Buffering capacities under stress. Natural systems, such as the ocean, have been a significant buffer to extreme warming, but there are limits to these buffering capacities, and current trends suggest they are being pushed towards critical tipping points. Addressing vulnerability by adapting. The global policy agenda needs to focus on improving adaptation as climate impacts become more severe, particularly in regions facing the greatest environmental risk to food security and home stability. Synthesizing climate indicators by tracking indicators such as the Earth's energy imbalance, as well as traditional indicators such as sea level and temperature, scientists will be able to better quantify the urgency of managing these global environmental shifts. Continued environmental alert. The persistence of record ocean heat levels and large-scale ice mass loss in 2025 demonstrates that the Earth remains locked into a path of consistent thermal rise that demands urgent global focus and a strategic international response. This report gives the key information on the Earth's energy imbalance, showing that the oceans and cryosphere are absorbing the vast majority of heat human-induced, and this leads to sea level rise and environmental instability. These interconnected changes represent an urgent challenge to human societies that need a transition to sustainability to lessen further intensification of these global hazards and to protect vulnerable populations.